Hi everyone. Today we are going to discuss the problem of the day on LeetCode, which is maximum twin sum of a linked list. So what do we mean by twin of a node in a linked list? Let's understand the concept first. So let's say we are given a linked list with even number of elements, and we are in our index starts from 0. So for a node at a position I, the twin of that node will be found at n minus I minus 1. So which means that in this case, in our example here, the node which is pointing to the value 5, its corresponding twin value is 1. And the node which points to the value 4, its corresponding twin points to the value with the node 2. Right? So moving on. So what's twin sum? So twin sum is basically for every pair of twins we find the sum. Right? So 5 plus 1 is a twin sum. 4 plus 2 is a twin sum, since they are twins. Moving on, a question says that we have to find a maximum twin sum. So let's say I want to find the sum of the first twin pair, which is like 5 and 1. So can we identify what's the start? 5. It's very easy. We would be given the start of a linked list. How can we move to the end of the linked list? We can iterate until our pointer dot next is null. So that's when we know that's the end of the linked list and we can find a sum. Right? But what happens when we increment the pointer, we move it to the next node? Our start now points to node with value 4 and our end points to nothing, just null. But actually our start is at correct position, which is 4, but we see end is at null. But actually we wanted, if I were to find the twin for 4, it would be 2. So from 1 we had to go backwards to 2, but since this is a singly linked list, there's no connection backward and we move towards null. And that is what the problem is. We actually had to move forward, and that is the trick of this question. So to solve this, what happens? Let's see. This is the first half of the linked list, 5 and 4, right? And this is the second half of the linked list, 2 and 1. What happens if we reverse the second half of the linked list? It becomes 1 and 2. What happens if this is done? Like if we reverse the second half of the linked list, we know that if our second pointer starts from here and our first pointer starts from here, 5 and 1 are twins. What happens if I move my first pointer by 1 step? It goes to node with the value 4. What happens if I move my second pointer by 1 step ahead? It points to the node with the value 2. Are they twins? Indeed they are. So this is the trick of this question. Okay, so what do? We have reversed the second half of the linked list, and my second now points to the first element of the second half of the linked list, and my first points to the first of the linked list. We find the current sum, which is 5 plus 1, 6. And we also have a maximum variable which stores the maximum value seen so far. Moving on, our first and second pointer moves ahead by 1 step. And again, our current sum is 6. And we have a maximum variable which stores the maximum value seen so far. Moving on to the code part, we see that I have two functions here. First is reverse list and the second is pair sum. So let's go to the first. Let's look at pair sum. So we are given the start of the linked list, which is named as head. So we have two pointers, low and fast. What do is here from line number 28 till 31, what we are doing is we are actually finding the mid of the linked list. Now, since this is a linked list with even number of elements, we want to find the first element of the second half and we want to reverse it from there, right? So that's why we have written fast is until fast is not null. We move slow pointer by a step and we move fast pointer by 2 steps. What happens when my fast reaches null? Our slow is at the first element of the second half of the linked list. Now what happens in line 33? We are reversing the second half of the linked list and we are storing the first element of the reversed half of the second part of the linked list in the variable pointer second. We have a maximum variable in line 35 which is initialized to 0. Why did we initialize it to 0? Since our constraint of the leetcode question says that the value would be between 1 and something. So yeah, that's why we have initialized the maximum to 0, else we would do integer dot min value. Now moving on to line 37 till 44. In this part what we are doing is, until our second pointer does not reach null, we are finding the current sum using head.val and second.val. We are adding it. We are finding the math sum using math.max of current sum and max sum. And we are, moving one step for head and moving one step for second. And in the end, we are returning maximum. So what are we doing? We have used 2-pointer approach here, right? In line 37 and 44 and also in between line 28 and 31. Moving on to reverse list function, we have a parameter which is like the start of the list, which is like named as head. For a reference here, what's the base case? We've used recursion here, and a base case is if a head is null or if there's only one element in the list. In that case, we just return the head. That's a base case. Else what happens is we reverse the list. How do we reverse the list? Let's say I have the start of the list and from start.next I reverse the list and I store that value, I store that start node here, the reversed half. Now I just have to see where does my head go. So I know now head.next in the reversed list would be at the end of the array, but my new end has to be my start. So that's why end.next is equal to start. And my start.next has to be null since that's the end of the linked list. And that's how we return the reverse list pointer. And we do this using recursion. I hope this was very clear and I was able to help you understand the concept of this question. Yeah, that was it from my end. Thank you.